definitions and some theorems.
Yep.
Probably, we'll see.
Trapazoid, bases and legs.
What our notes are over today is trapezoids.
Oh, I need a great check today too. Yeah. Yeah.
So first off, a trapezoid is a quadrilateral with one pair of opposite sides parallel. With only one pair of opposite sides parallel. So the first question I would ask you is, would something like this be a trapezoid? If these two sides are parallel, then yes. So it could look like a lot of things. As long as one pair of opposite sides are parallel, then it is a trapezoid. The way you have generally seen trapezoids drawn is an isosceles trapezoid. In a trapezoid, there are always two bases. The parallel sides are bases. So you have a base 1 and a base 2.
Is it always base 1, base 2?
Nope. You can call either one of them base 1 or base 2.
Base 3.
There's only two.
Do you like average the base multiply by the height of the area?
You do. Now, this one would be base here and a base here. And it doesn't matter which one you call base 1 or base 2, and I'm having a hard time drawing these. Okay? The other two are legs. So this is a leg and a leg. This is a leg. And here's the other leg. In an isosceles trapezoid,
Leg. I think you are.
in an isosceles trapezoid, the legs are congruent. Tell me, why could we not have congruent bases? Why can there not be congruent bases?
That would be a parallelogram.
Because it would be a parallelogram. When one pair of opposite sides are both parallel and congruent, you have a parallelogram. So in an isosceles trapezoid, it is the legs that are congruent. If I find the midpoint of each leg and draw the line that connects the midpoints of the leg, here is another one, midpoint of this leg, midpoint of this leg, the line that connects the midpoints of the legs, then I am drawing a segment that's called the median of the trapezoid. So the segment that joins the midpoints of the legs of the trapezoid is called a median. Yes, segment joining the midpoints of the legs is a median. most of the, well, I don't know about most of, but one of the theorems we're going to be covering will be true for just an isosceles trapezoid. So Theorem 518 says the base angles of an isosceles trapezoid are congruent. Trying to get a trapezoid here. What we are going to be given
Base angles.
is that this is a trapezoid, which means we have two sides parallel, and it is isosceles, so we have the two legs congruent. So BC parallel to AD, and AB congruent to CD. What we want to prove is that the base angles are congruent, which would mean angle A and angle D would be some of those base angles. What would be another pair of base angles? These angles right here, angle B and angle C, would be another pair of base angles, right?
So in like English, when we look at the word base, it's like pause or something is the base of it. So would you actually just ignore that?
When you're talking about a trapezoid, the two sides that are parallel are called bases no matter what orientation it has. Same with a triangle, you can use any of the sides as the base. You talk about the base, and then the height of the triangle will always be perpendicular to the base. So you can use any of those sides because the triangle can be flipped in any direction, right? So any side can be a base as long as the height is perpendicular to it. Okay. So what we are proving is that angle A is congruent to angle D, and also angle B is congruent to angle C. To name these angles though, because I know I'm going to be drawing the transversals, to name these angles, I'm going to name them angle BAD and angle CDA. And angle ABC congruent to angle BCD.
Make a triangle.
I am. I'm going to make some triangles. The way I'm going to do that is draw these two diagonals. Which in an isosceles trapezoid have to be congruent, by the way. We're going to be able to prove that we have congruent triangles. What I know, since these lines are parallel, is that we have some congruent angles. I also know that we have some congruent sides. You know what? I think I'm doing this the hard way.
There you are. There you are.
Let's do it the easy way. I don't have to prove congruent triangles.
Are you gonna erase something?
I'm going to erase the diagonals.
Well, alright.
Yes,
know what? Let me pause. All right. What we decided is if we make a parallelogram, from B, let's go parallel to CD, which means, let's call this point X, and we have now a parallelogram BXDC. It is. And opposite sides of parallelogram are congruent, right? Which means that this side and that side are going to be congruent. So, since opposite sides are congruent, BX will equal CD, which equals AB. Now we have an isosceles triangle. And in this isosceles triangle, the base angles are congruent.
Is it chapter 5?
So isosceles triangle ABX.
Okay, that's supposed to be now an isosceles triangle or now in isosceles?
In. So the base angles are congruent. Which means angle BAX is congruent to angle BXA. Also, we have parallel lines with this parallelogram, and I know that corresponding angles are congruent. So, angle D will be congruent to angle BXA. Which means that it is also congruent to angle BAD. So I have part of what I want to prove. I have that angle BAD is congruent to angle CDA. Now, since these angles are congruent, and with parallel lines, same side interior angles are supplementary, then these two angles, angle B and angle C, will be supplements of congruent angles. So I can state, let me write it the same way I have it up here, angle BAD is congruent to angle CDA. Because same side interior angles are supplementary, and supplements of congruent angles must be congruent. Okay, we will finish. Well, I have like 3 minutes here, so let me go ahead and wrap up. And then we'll finish things tomorrow.